Eastern, North, and South Carolina sales representative for Master Gage Tool. Master Gage Tool was founded in 1986 as a metrology distribution company, representing the leading metrology equipment manufacturers in the world. Today, we have 2 sales offices with calibration labs, one located in Danville, Virginia, and the other in Greenville, South Carolina. Each lab is 17025 accredited and offers dimensional electronic calibration with a vast scope of services. Today, we are hosting a virtual demonstration day on Nikon's Elements digital imaging software. The virtual presentation will include live product demonstrations and in-depth discussions of Nikon's digital imaging software and associated hardware. The presenters today are Gary Poirier. Gary is Nikon's Southeastern sales representative, along with Rob Patton, who is Nikon's digital imaging product specialist. During their presentation, you are encouraged to ask questions through the chat platform on the bottom right of your screen. You may type in your questions, and Rob and Gary will be happy to answer them at the conclusion of the demonstration. Again, welcome to Master Gage Tools Demonstration Day on Nikon's Elements digital imaging software. At this time, I'd like to turn it over to Gary. Good morning, Gary.
Good morning, Chris. So first, I'd like to thank you for joining us today. And I'm going to spend about the next 10 to 15 minutes talking about Nikon's imaging software platform, NIS Elements. NIS Elements is an investment into the ever-changing requirements of your lab. It allows you to grow and change as your systems grow and change and as your components grow and change. Elements is easily upgradable, simple for training, and easy to use. It allows you, your technicians, to develop a platform that can be passed on through generations of your laboratory's growth and transitions. To help you do this, we offer both online and on-site installation training and support. We want to help you meet your requirements today and your requirements tomorrow. Elements software is built for performance. We envision a system that you can put on any optical component and maximize its performance. Once you add a Nikon camera and Elements software, you now have a digital platform to meet your laboratory's needs. Elements also has the ability to control third-party stages for image stitching. We can do Z-stacking automatically. We can even do autofocus to maximize your laboratory throughput. We believe that having a single software platform for your imaging needs is vital. We want an operator or technician to walk up to either a stereoscope, compound microscope, confocal microscope, and have the same interface controls, workflow, and speak the same terminology when they're working, no matter what kind of equipment they're using to get the imaging you need in your analysis requirements. With one simple platform to learn, users can easily switch between their microscope systems when requiring different imaging. It's as simple as going up and clicking on a button to change from a compound microscope for high resolution or a low resolution stereo microscope. We can even bring in images from other platforms. As long as they have a measurement bar, we can bring it into Nikon Elements. We can use a measurement bar to calibrate our system and then perform analysis on those images. Elements continues to grow as your requirements grow and as the industry changes. A good example is grain sizing. Grain size is a difficult thresholding technique which requires very good sample preparation, which is not always the case in the real world. And that's the reason we developed AI to support grain sizing, to make it much easier to come up with an ASTM standard number. When you're doing items like grain sizing or image stitching, with Elements controlling the X, Y, and Z axis, you can easily automate these applications. That way you can increase your lab's throughput when you have to do stuff like extended depth of focus or image stitching. Elements even seamlessly interfaces with third-party stages to allow measurements beyond the field of view. And what we're referring to beyond the field of view, when you're looking through a set of eyepieces, let's say you're looking at a crack. You can see the beginning of the crack, but needless to say, you can't see the end of the crack because it's out of your field of view. When Elements works with a stage, we can actually start at the beginning of the crack, put a mark there, then move the stage beyond our field of view and put another mark down and make an out of field of view measurement, which is very quick and very handy when you're doing large samples. Just as importantly, or maybe even more importantly, Elements is designed to export this data. You've captured these images, you've gathered the data, you've put your numbers in. Now you need to get it out to report that you, your company, and your lab can depend on every day. And that's where Elements shines. Not only do we have our internal reports that we can export to Excel files or other type of reports or analysis platforms. And that way you can build a report that can really benefit your company and your engineers. With this customizable user interface, we really envision, like I said, once again, a system that doesn't require a Nikon stereoscope or a Nikon microscope. We can put this to any type of microscope or stereoscope and turn it into a digital platform. Whether you're just going to want to take a picture for simple measurements and maybe some annotations and a simple report, or if you got to do some extremely powerful, complex workflows for automatic imaging and routine analysis. Nikon Elements can handle all that, and we can build it so each user sits down and has their own interface to work with that they're comfortable with. And they can share that with other users and build a platform that's very easy to use for all your technicians. Now, the Elements platform actually comes in 3 styles. We have D, which is documentation, which meets 90% of the customers out there. We also have BR for basic research. If you're doing some 3D modeling or you're doing a lot of pushing your stage around, or Z-axis for image stitching or extended depth of focus, then we might look at the B to actually bring that to you, especially if you want to do some 3D modeling. And then there's AR, which is advanced research. And that's if you need to do 4D modeling or other complex analysis. So we have those 3 modules. And then I want to talk to you about the actual modules that most of our customers use. So the first one is HDR, which is high dynamic range. You're looking at these 2 images, and if you look at the bottom image with HDR, this is basically what your eyes see when you look through the eyepieces. Your eyes and your brain are your most powerful tool, and its ability to actually set exposure settings and look in the image and know what it's supposed to see allows you to look through the eyepiece and see that type of image. It doesn't happen with a camera. It has to be told to go take several images, adjust the exposure settings in order to put those together and reproduce what you see with your eyes. It's kind of interesting when people talk about digital microscopes. I'm always surprised at ones without eyepieces, because how do you know what you're supposed to see? When you look through your eyepieces, you get a very large field of view. Your eyes have the ability to make the lighting proper, and you're trying to duplicate that with a camera in order to achieve the same results. And without eyepieces, how do you really know? The main reason customers buy Elements is for this option right here: manual measurements and image annotations. This is a very simple, powerful program for measuring circles, angles, drawing straight lines, drawing crooked lines, making annotations, and generating reports with that data and information. It comes with every one of our systems, and it's a very powerful tool. Next is extended depth of focus. Samples aren't always flat, and we want to have an image that shows the entire sample in focus. So this is an example of a ceramic capacitor sitting on top of a printed circuit board. If you look at the first image in the top left, it's focused on the printed circuit board. And if you look at the image on the bottom right, it's focused on the very top end of the ceramic capacitor. Now, it shows 3 images to capture this, but that's incorrect. It really has many, many images to capture the full depth of focus on this type of image. And when you combine this with image stitching, it's a really powerful tool. Auto measurement, or as some people call thresholding. This is where we can take a color, as we have an example here, come up with an area percent. We can take a circle or circles and tell you how many they are, how large they are, how small they are, what's the average. Thresholding or auto measurement object counting is a very powerful tool. It's also how we accomplish grain sizing analysis. The thresholding allows us to visualize the grain boundaries, which in turn allows us to categorize the actual individual grains and come up with an ASTM standard number, graphs, and min-max numbers. Thresholding using grain size analysis requires a very well prepped sample in order to accomplish this. That's the reason we developed AI to work with grain sizing. It allows you not to have quite the perfect sample and still get the information you need by the AI knowing that a scratch is not a grain boundary or twinning is not a grain boundary and automatically making the adjustments for it. We do the same thing with cast iron analysis, but instead of grain boundaries, we're visualizing the ferrite and graphite content, colorizing those, and generating reports and our information we want to export. Image stitching. This is where we spoke about the crack, the ability to see the entire crack in one image. So what we do is we actually can move left or right, top or bottom, and line up the very end pixels. And since we're measuring with pixels on the monitor, when we put these images together, it allows us a measurable image too. So it's very handy on these large samples when you want to capture everything together, or if you have a failure or crack. So those are the three modules that most of our customers use consistently. We have some advanced modules that Rob will talk about later on. Right now, I want to talk about the 4 industrial cameras we offer to work with Elements. First is the DS1000. It's our standalone camera that's designed to work with a mouse and a monitor. Let's say you have a stereoscope, you just need to grab some images, maybe make some documentation, maybe every so often you got to export them somewhere. The DS1000 allows you to do that with just a monitor, and if you want to save the information you collected on the monitor, you press a button, it puts it on an SD card, and you can take that anywhere you want to go. Now, a lot of people look at this and say, it's just a 2 megapixel camera. How does that even work? The reality is that in order to capture these images we're trying to grab, we don't need a lot of megapixels. What we need is big megapixels that pull in lots of information and allow lots of light in. If I'm taking a picture of a landscape, yes, 40 megapixels, 50 megapixels, great. Lots of information, lots of light. But when you're trying to take an image that's been magnified, it's a very small image. And what we really want is the ability to bring in lots of data and lots of light. And that's how our CMOS chips are designed. So our workhorse camera is a DS-FI3. It's a 5.9 megapixel super color resolution because it's a Nikon designed chip and camera and glass, which we manufacture all in-house. It offers ultra 4K resolution. So even though it's only 5 megapixels, it actually is UHD 4K. So we're going to use it for our demonstration today, but you won't actually really be able to see the resolution because we're doing this over a WebEx. The only way to do it is to see it in person. Now, we have a few customers that really want to capture what your eyes see through the eyepieces. You can't quite do it, but you can get close, and the DS10 allows that. When you want to see a lot of surface information, kind of your topography of the surface, the DS10 allows so much information, and you start seeing that on your Ultra 4K monitor. So it gets about as close as you can get to the human eye as far as resolving these images. Now, our DS50 is designed for looking for very small defects on like the back of a silicon wafer. It can pick up submicron defects when it's scanning across the surface. So it's a very specialized camera. Now that I've talked a little bit about the camera, we're going to have Rob do a live demonstration with the Nikon LV150 transmitted light microscope using the DSI FI3. And once again, what you see here is not what you're going to see in person. If you really want to see how this works, have him set up a demonstration and bring it in, and it's really impressive. Well, Rob, please take the time and show us how these 3 modules work live in Elements, and I'm going to turn it over to you.
Thanks, Gary. Thanks, Chris. Appreciate it. Welcome, everybody. Glad to be showing you the Nikon NIS Elements software package. I'm just going to go ahead and share my screen and go live so you can all see. So here is the NIS Elements platform. Elements has a long history here at Nikon. It's approaching 20 years that this software has been available in the marketplace. I've been involved with it from the very beginning. So I've seen all the changes through the years, and the software developers are excellent. They're very responsive to improvements and changes over the years. So I've really seen this come to fruition over the years, and it's just a really nice software interface. I've worked with a lot of software interfaces in the microscopy world. I'm a little biased, but I really believe this is the best, user-friendly, most powerful, and easy to use software platform. So this is what you're going to see. And as Gary said, we have 3 different versions: Elements D, Elements BR, and Elements AR. I'm showing you Elements D. It's what we sell the most of. It's our basic package framework that, probably 90% of what we sell is the Elements D package. It's going to give you most of the features you're going to want. But this is, the general overall layout. So just a little bit of a tour of what this looks like if you've not seen it before. What we have are different layouts. And when you first open the software, some people like this compact layout. It's really unchangeable. All the dialog boxes are fixed. If you're an occasional user and you just want this to always look the same every time, and you're just doing some real basic image acquisition, saving and measuring, this compact view is kind of nice. And then we have all these customizable views. You'll see going across the top here. I'm not going to go through all of these layouts, but I'm calling this one advanced, the advanced layout. But we can save this layout and give it a specific name. I usually would call this either the user of the microscope's name or the company's name. But we can create these individual layouts. And so over on the right-hand side here, you can see I have the acquisition dialog box and the annotations and measurements dialog box. Going across the bottom, I have my opened images dialog box. So if I capture an image by hitting the image capture, you can see the new image appears on the bottom left. And as I capture more images, this film strip just keeps populating to the right. And I can bring in images by double clicking in the film strip below. So these 3 dialog boxes are the most common. If I right mouse click, you can see there are 4 categories of dialog boxes. So there's lots and lots and lots of dialog boxes that I don't have in my layout right now. But let's say maybe I wanted to add video acquisition. So this is a special dialog box that allows me to record video through my camera system. So, this could be my layout. So I could, you can see there's many more. If I go to analysis, there's some layer thickness modules, some of these other modules that Gary talked about, and I'll allude to a little bit later. So we can just keep populating these dialog boxes just the way we want it. And then I could, rename this my layouts. So very customizable for each individual user. And then just another part of the software layout and setup system that's very, very, very popular amongst our users is our user rights system. So I've just created layouts, and I may have some calibrations, and I don't want other people to change those. So there's this very powerful user rights setup system. You can create administrators to the software. The administrator can then, you can have different guest logins. We create up to 4 different categories of logins. And then you can start unchecking boxes if you don't want someone to modify layouts, you don't want someone to modify objectives. This can all be controlled. And this is very powerful for multi-user labs. You're going to walk up to the system, log in with your account, and you're going to know it's going to look exactly the way you left it. And people can't change very important aspects. Mostly the objectives and calibration is something you just don't want anybody changing. And our login system can be through Windows logins, or it can be just, if everybody logs into the PC through the same Windows login, we can set up an NIS Elements login system. So very powerful as far as controlling the situation, which is just, you're in a laboratory, you're dealing with lots of instruments, lots of different software packages. You don't want to walk up to the software and have that be an issue of where did all my controls go? So that's just a little bit about the overall general layout of the software. Let's just get right down to what most people do. So there's some redundancy. You'll see a green play button up here. We see a live play button up here. They both work the same way. So you should all be seeing my live image as I move my stage back and forth. So this dialog box here, one of the most important one of the most important aspects of the software you really want to understand is the control of the camera. So not a lot here, but it's important. So this is the DSFi3, as Gary mentioned. It's our most popular camera. It has a couple different resolutions built into it. I'm running it at the lower resolution of 1440 by 1024 versus the higher 2880 by 2048 full 6 megapixel. Just through the internet WebEx system here, our bandwidth might be restricted. So I'm going to run this, then we can independently change the resolution of the live and the capture. Most of the time, I really do run both of these at the full 2880 for both live and capture. Because this camera is USB 3, the speed of it's quite high. So even at the high resolution, we're getting close to video rate, 30 frames per second. So we set our resolution, we set our exposure time, and the exposure time can be set on continuous auto exposure. And this is probably the most popular setting. As I change my objectives, you can see the auto exposure very quickly readjusts automatically to the magnification that I'm set at in the microscope. Or you might have situations where you want to dial in a specific exposure time, and I can choose from this drop-down list. The camera has gain built into it, and of course, our auto white balance is very important to understand that system on your microscope. My particular microscope is a 12-volt, 50-watt quartz halogen bulb. It's going to burn a certain color at a certain voltage setting. We do have our microscopes now are available with LED lamps. With an LED lamp, the advantage there is as you turn the light down, it doesn't change color. So you can see on my system, if I put this on continuous auto exposure, it's going to continuously update the exposure. But if I turn my lamp down, the image gets more yellow. As I turn my lamp up, the image is going to get more blue. You may have seen some images and some presentations or articles and publications where they're blue or yellow. That's because they didn't set the white balance. So it is important if you're using a quartz halogen bulb to set a white balance. I mean, typically I would put a white specimen or a mirror on the stage and just hit my auto white balance button, and that's can all be saved as a setting on the system. So again, because our goal here is capturing great images, this is the most important part of the software to really understand the camera controls and get those set up right. So as far as capturing, I've got an image, I want to focus. So I can zoom in with my mouse wheel. I'm just rolling my mouse wheel forward, and so that I can adjust the focus on the microscope that way. I can also use this very popular magnifying glass up in the top left corner, so I can magnify some part of the image and focus on something in a magnified view while I'm still seeing the rest of the image in full mode. There's also at the bottom of our software this black progress bar. As I move out of focus, the black bar moves to the left. As I come into focus, it moves to the right. And when it's maximized, that's electronically saying that's our best focus. So once I've done that, I want to capture. So we have some redundancy here as well. My capture button up here, or capture button over here. I've captured my image. Now, I have a scale bar already shown in the image here that can be turned on or off. And of course, in this case, let me go back live again. My particular microscope is not communicating with my objective. So I'm actually on my 5x objective, but I have the 50x shows over here. So I'm going to click on my 5x objective setting here. So you can see that that scale bar changed. So we sell this both ways. If we had our microscope systems with the intelligent nose piece, as I change my objective, this would automatically change. And that actually is highly recommended if you're going to be purchasing a new microscope. Ask about the intelligent nose piece. It eliminates mistakes of the person not remembering to check the right button over here. So in this case, capture my image. I've got my scale bar in here. If I go to my file, save as, we have several different types of file formats. Of course, the two most popular are going to be the most popular, of course, is going to be JPEG. Most of our customers save as JPEGs. If this box is left checked, it's automatically going to burn annotations in, like that scale bar that you just saw. It's going to save the calibration with the image. So it's really nice. The most popular way, it's going to shrink the file size, still keep the calibration, and then automatically burn in your annotations and measurements and scale bars. There is also TIFF images can be saved with layers. So I could save an image with scale bar as a layer. My measurements could be a different layer, annotations. Plus it saves all kinds of extra information. Exposure settings of my camera. If I have a motorized stage, it's going to save XY coordinates. So a lot of information can be saved with the tagged image format, the traditional TIFF. But again, most of our customers use JPEG images, and that is what is most commonly used. So we've seen the scale bar. Go back live here again. Maybe just move to a different image. I'm going to capture this image. The next most popular part of our software, after capturing our image and maybe throwing the scale bar on it, is going to be the annotations and measurements that Gary alluded to earlier. Let's clear out my dialog box here. So I'm not going to go through every single one of these controls, but just to kind of give you a tour through here. This top section is annotation. This would be, of course, for text and arrows, and just really sort of annotating different features of the image, boxes, squares, so all non-measurement type annotations. Then we get into this whole row you see here, just basically like 10 different ways of measuring length. So as I click, the first choice is 2 clicks to give me the length, or click and drag, measurement between 2 parallel vertical bars, 2 parallel horizontal bars, or 2 parallel lines at some angle. And as I capture these measurements of these length measurements, you can see it dropping into this table over here on the right. So it'll accumulate the individual measurement data as well as the statistics down at the bottom here. So we've got mean, min, max, standard deviation is all being captured. So the next row, area measurements, we will call them. So there's some specific measurements I've got dialed in here. So if I choose my first choice here is, I'm just going to manually draw around an area. So it's going to give me that area in square microns. In this case, I am calibrated in microns. And just to kind of show you this over here, if I right mouse click, I can very quickly change my unit of measure. If I want to go to millimeters, and it automatically converts everything on the fly. So very easy to change between unit of measure. So when I choose, it's measuring area, but in the table you can also see I'm measuring equivalent diameter, min ferret, which is like a min diameter, max ferret, it's like a max diameter, and then perimeter. And again, accumulating statistics down at the bottom. There's a very nice tool in this area measurement called auto detect. And it works really great for images like this. If I left click inside of this white area, I can sort of expand and contract my mouse till it's just filling that area. Then I right click, and it will then give me the measurement of that whitish area and not count the brown around it. So it's like an eyedropper for quickly measuring area measurements. Of course, angle measurements are involved here, 3 different ways. My quick way of just drawing my 2 lines to get my angle measurement. We've got radius and diameters, so we can draw circles. We can draw 3-point circles. or endpoint circles. So all three are going to have the effect of giving you the diameter and radius. We have some simple count and taxonomy tools in here too. Probably not real commonly used, but let me just delete all these. So if I wanted to just click on X number of objects and keep track of how many objects I clicked on, it's in lieu of having a hand clicker and writing down how many things you counted. So again, annotations and measurements, very, very our most common tool. It's comes with the base package of the software. And just to kind of show you quickly, again, we talked about accumulating data and exporting. So I can export this data in many ways. The most common probably is going to be to send it to an Excel spreadsheet. And I have control, before I send this to a spreadsheet, I can go into my data export and say I just want the name of the image and the length to be exported, and control all that. Just hit my Excel export, and then dumps that data into the Excel spreadsheet. Or, you might want to do a report. There's some real quick built-in reports, length to report. It's going to dump these to a table, but I can create a custom report that would put the image along with the measurements in a custom report with your company's header at the top and so forth. So many different ways of exporting this data. One more thing that I'll show you that's you get with the base package of the software. So far we haven't talked about any add-on modules. Everything's modular with our software. You start with the base package, NIS Elements D. And so you get everything I've showed you so far: capturing images, saving images, scale bars, manual measurements that I just showed you. You also get what's called, I'm sure I'm on 5, the manual large image stitching, which Gary talked about a little bit earlier. So here I'm on my microscope. I'm on the 5x objective. It's the lowest mag I have. We do have lower mags. We have a 2.5 and a 1x, but I don't have them on my microscope right now. So I'm at my lowest mag, but maybe I am not quite seeing everything I want to see at this magnification. So I can go to Acquire, Manual Large Image, and it prompts me to remember to go to manual exposure time. So this is a situation where you don't want to be on auto expose because you don't want these images to be different brightnesses. So you can see my live image, and I have a green box around my image. So I'm grabbing my, manually moving my stage in the X direction, and you can see that green box move to the right. And when I get, I'm gonna go ahead and turn my auto capture on because this works pretty good for auto capture. So as I keep moving my stage, that green box is very close to turning pink. So when it turns pink, I'm going to stop, and you can see it automatically added the next frame. So I could keep going to the right, or in this case, I'm going to go down, and green box, waiting for it to turn pink. So it turns pink. I'm going to stop. So I added that frame, and then let me just move back this way to the left. It's got green box, waiting for it to turn to pink. And I stop, automatically adds that, and let's say that's good. I'm now seeing everything I want to see in one field of view. I'm going to click on Finish, and now I have my new stitched image. So it's basically just taking 4 images and stitched or sewed them together. Does a really nice job. You will have a very hard time finding the edge of the stitch. It's one of the better stitching programs that I've seen in software for microscopes. So we now have this large image, which we could still, as Gary talked about, even after you've stitched them, we could measure across the stitched image. So very powerful tool, and again, included with the base package of the software. So the next, probably most common module that we would work with is, I'm going to close this and just start with fresh live image. And I'm going to go to my 50x objective. And let me go to the edge. Coating thickness on this particular sample. Go one more to the 50. So, all right. So I'm at 50x objective, 500x to the eyepieces. Just a quick note about that. That's kind of interesting. People always ask, what magnification am I at? Well, it kind of depends. If you're looking through the microscope eyepieces at 50x, 500x, but what is it on my screen? Well, that's going to depend on the monitor that you're using. Nikon does have this really cool feature called Show Physical Zoom. As it sits right here, and you can see a little vibration on my table. As it sits right here on my monitor, I'm at 1084x. If I take my mouse wheel and zoom in, that magnification on my monitor is increased. So this is a nice feature that actually shows the actual on-screen magnification. It's called Show Physical Zoom. But back to what I want to show you. So we have an image at this higher magnification. The depth of focus is much smaller at the higher mag. So you can see as I move my manual focus up and down, there's some parts of the image that are in focus and some parts that aren't. So we have this module called EDF, and it's going to show up under the applications. And right now I'm going to, we can do this automatically with a motorized Z drive, but I'm going to show you the manual method. So in the manual method, I essentially just start at one end of the focus and hit start. And you will see on the right side of the screen is the live image, and the left side is the image that's going to be created. So I'm going to manually move my focus through the Z planes, which you'll see the image on the right changing, and the image on the left is being built. I just keep going until I'm all the way through my focus, and then I'm going to hit finish, and then it's going to process this. And so this, as Gary mentioned, this is it's analyzing. It has analyzed several different Z planes, but it's going to create just one two-dimensional image when this is all said and done. It's not going to be a stack of images. I mean, we can capture stacks of images with a motorized Z drive, but in this case, it's just accumulating that data. So now we've got one nice all-in-focus image created by the EDF. So very popular. Most of our systems in the industrial world will be purchased with this EDF module at least. One other module that's an add-on, very commonly used. It's probably a little more beneficial on a stereo microscope where you may have shiny objects, ball bearings, solder joints, any metallics. So what happens here is, I'm just going to use this sample. This is a cross-section, a metallurgical cross-section. And I'm just going to use this as an example because it will demonstrate what this does. So as you look through the microscope eyepieces, and this is the Bakelite material in your sample. It's not part of the sample, but it's darker. And this is brighter down here. If I look through my eyepieces, my eyes kind of adjust and I see this nice transition of colors. But the digital camera, all digital cameras can kind of have a hard time when you have dark areas and bright areas all in the same sample. So what we have is called the HDR, high dynamic range. You guys, you all have these on your cell phones too. It's if you're taking a picture of someone with the sun behind them, it'll adjust for the brightness of the sun and the darkness of the person you're taking a picture of. Same concept. So I usually just use my capture reflection free image. It runs the algorithm on its own, and I did that very quickly, so you can see the concept of. So it used longer exposure times for the dark area and shorter exposure times for the brighter areas, and combine that all into one nice image. So ADF, HDR, add-on modules to Elements D package. That's those three together are what we sell the most of. If you're looking at purchasing a system, I would suggest all three of both of those modules, in addition to the base Elements D package. Almost everyone can use those options. So that concludes me. I'm going to stop sharing my screen here. My live. Okay. And I'll go back to the slides. So just a summary of what I've just showed you. Manual measurement and image annotations and manual image stitching you'll get for free. and EDF and HDR are add-on modules. So there are many other advanced application modules that we sell for the softwares. These are all kind of beyond the scope of this webinar right now. We'd be glad to schedule individual demonstrations for any of these if they're of interest to you. But we have auto measure module, which is basically if you have a sample where you want to count objects, count particles, measure percent area porosity, that is an add-on module that we have. Gary talked a little bit about our grain size analysis for measuring ASTM grain size of metals. This is an add-on module, and he alluded to our new AI module, which is really good. If any of you out there are metallurgists and you're doing grain size, you're going to want us to show this to you, preferably on your own samples. It's fantastic. In the grain size world, most people are used to the old way is you look through the eyepieces, then you look up at the wall at your ASTM chart and estimate what your grain size is. So a lot of people do it, but a lot of people wanted to do this on software. So software has been available for years for this, but it's been very, if the sample is not perfectly etched and prepared, it's hard to find the grain boundaries. So now using AI, our software module is very, very good at finding grain size boundaries and calculating that ASTM method, grain size number. So if any of you are doing this, it's really great. Contact Chris and Gary about this. And of course, the cast iron analysis module, separate module for nodularity, graphite size, and ferrite content. Gary touched on that. We have a module for filter analysis. They're sometimes called cleanliness. The ISO 16232, you're typically filtering fluids, oil, washed part liquid through a 47 millimeter filter. It collects particles, debris. So we have a specific module for used along with a motorized stage to scan that filter and count the particles, metallic flakes, and fibers per this ISO 16232 method. We have systems for semiconductor defect inspection, all different size wafers. So we can set up manual inspection with a user, or we have our newer automatic, I should say semi-automatic defect inspection system, which is really nice. Automatic large image stitching basically does just what I showed you a few minutes ago. Manually, we can use a motorized stage to automatically you can tell it, you can go to the top, bottom, left, and right, or you can just say, scan a 20 by 30 field image. You can scan your whole surface of your sample and create this huge stitched image automatically using a motorized stage. And then using our Z drive, either for a single field of view or through a stitched field of view that maybe has some Z stacks collected, we can create the 3D topographical maps, get some real rough Z height measurements. It's not, this is not like a profilometer or confocal type Z height measurements, but because our Z drive keeps track of the different focal points at different Z heights, we can get some rough Z measurements. So yeah, a lot of different advanced applications that can be added on. They're usually specific to customers' needs. So for sure, reach out to your salesperson. We always like to get samples. I can do preliminary sample demos on my system and then ultimately on-site demos, as Gary mentioned. So please feel free to reach out to Chris and Gary. And I'm going to kind of turn this back to Gary and then we can answer some more questions later.
Thank you very much, Rob. We appreciate you showing those modules to us. And as you can see out there, that we're set up to meet the most challenging applications right now. And we'd love to show it to you. Every day we hear of unique and different applications because every industry has their own needs. And Elements can help conquer those requirements. And we'd like to hear from you on how we can help you conquer your needs within your lab. So we're going to turn this over, some question and answers, and we really look forward to it. And now it's time for your questions.
Yeah. Thanks, Gary and Rob. That was a really good presentation. To our attendees, if you have any questions about the presentation, please feel free to type them in the chat panel at the bottom right hand of your screen. This concludes our demonstration segment. We would ask that you stay with us during our question and answering session, and then we'll provide details on scheduling a specialized demonstration at your facility. So at this time, I'm going to open it up for questions. At the moment, it doesn't look like we have any in the Q&A, but I had a couple of questions text to me. Rob, how accurate is the measurement, or excuse me, how accurate are the measurement tools and elements?
Well, accuracy is really going to depend on the magnification that you're using, but you will see, you saw when I showed you earlier the calibration values. So each magnification had a value. So just kind of looking back, for instance, on the 50x objectives that I was using, 1 pixel was 0.17 microns per pixel. So 0.17 microns is the size of 1 pixel making up that image. So of course you couldn't measure something based on 1 pixel. You usually need, I give a rough estimate of 8 to 10 pixels to measure something. So I usually give that rough, so if I multiply the 0.17 times 10, that's maybe roughly what the accuracy or precision would be of the measurement at that magnification with that camera, with that microscope. There's a lot of things that come into play, so it's really system dependent. At the end of the day, you really want your own calibration standards and ways of verifying your own calibrations, and round robins to see what kind of variation you're getting from user to user, because that can affect things too. I mean, someone's clicking and dragging a line across something, how accurately are they finding the edge? So it's system dependent, user dependent, and that you should establish your own guidelines there. But essentially, it kind of goes, I go by that rough calibration per pixel, multiply it by 10. That's roughly about how small I could go.
Okay, great. We have a question. Excuse me. Let me get back. We have a question about service after the sale and how responsive would we be if only one machine before a rep could review on site. And then in coordination with that, someone is asking if the machine needs to go back for repair, we give me a loaner. So the nice thing about working with Master Gage and Nikon is that Master Gage has territory reps located within the territory that they cover. So they're frequently traveling their areas of responsibility and can come on site very quickly. As backup, we have Gary, who's located in South Carolina, and he supports us as well. And if we're unable to make it there, we would have that backup support from him. As far as loaner systems, Master Gage Tool does stock some systems, and we do have some demo systems, as well as Gary maintains some. It's sort of a difficult question, depending on if we have a system that we would be able to loan you one. One thing I'll say about Nikon, and Master Gage represents over 200 companies, is that they truly have the best warranty of just about any product that we sell. The warranty is 5 years on mechanical parts and 1 year on electrical. So I think that demonstrates the quality of the product, and we rarely have issues in the field. Not to say never, but it's very reliable systems.
So Chris, can I add something in?
Yes, please.
So one of the nice things about Element software is if you have the ability to use your company's teams, which most companies have now, we have the ability to support you online. So it's just a matter of setting up a Teams meeting. We can go in, and if you have the Teams app, we can actually take control. If you don't have the Teams app, we can direct you to what buttons to press to solve most software issues, because that's what we're talking about. Someone's come in and done something to your software. You don't know what they did. You don't even know where to look to start. You set up a quick Teams. We come in, show you what's happened, and we're right back out the door. And that's very quick and painless. And that's typically what happens with these camera and software systems. Someone starts, we don't lock it down all the way. We give them a little flexibility, and they press the wrong button, and we have to help you kind of figure out how to get back to where you were.
Okay. Another question was about software upgrades. Are they free for the life of the machines, and are they sent to us via links?
Yes and no. They are sent via links, but they are not for the lifetime of the software. So each year you can update the software. If it's Elements D, it's $480 a year, and you update it, and that brings you all the new applications. And a lot of things start out at a price. Like image stitching used to be very expensive. So if you have an old version of Elements, you might have paid for image stitching. Now it's available. So when you update things, you automatically get the free software that's added into it, what's ever available, and you have the newest system. Now, if you buy Elements, and let's say you buy an Elements today, you're running on a Windows 10 computer, as long as you stay on Windows 10, you won't have to upgrade Elements to use it for your lifetime. You only need to upgrade it if something changes or if there's something you want to add. So if you're going to have to go to Windows 11 and you're running Windows 10 software, in order to make that jump, you will have to get your software up to date. So you don't necessarily have to update your software, but when some big change comes, you have to bring it up to date at that point in order to make those changes.
Thank you, Gary. Bear with me. There's a couple other questions. Are there only a few microscopes Nikon makes that are compatible with the camera and software? And then also, what is the expected maintenance and professional cleaning and maintenance of the systems?
Well, the presentation today is based more upon your current optical components. We are not really referring to Nikon microscopes and stereoscopes here, but they're Nikon stereo microscopes are built to high standards. Typically, unless someone abuses them, there really is no maintenance. You can have someone come in and clean them once a year, which is nice if in dirty environments. If it's a clean room or a clean environment, there's really not much you can do. But referring to Elements and cameras and Nikon software, you can take that and put it on anybody's stereoscope or microscope and get all the benefits of turning your current system into a digital system. There's a lot of talk nowadays about digital microscopes, digital stereoscopes. And the reality is you can take any microscope and any stereoscope or any optical component that you can attach a Nikon camera to and use Element software, becomes that digital platform that everyone's talking about. A digital platform refers nothing but taking an optical image, turning it into digital information, and then presenting it back to you on a monitor. And so any microscope, once it's developed with a Nikon camera and software, becomes a digital operating system.
And just to piggyback on that, I mean, basically all of Nikon's microscopes that we manufacture today have photo ports that allow us to put our camera and software on. And to Nikon's advantage, I mean, our microscopes last a long time. But what changes over time, though, is the camera and software. So I've been doing this a while. I have some customers that are literally like on their third, some maybe fourth camera. Maybe their microscope's over 30 years old, but because if they maintain the microscope, it had a photo port to begin with, we can change the camera technology and software over time. So that's the advantage, of a traditional microscope with a separate camera and software, as opposed to it being integrated within a box. Once that box goes obsolete, you got to buy a whole new box. Yeah. With the Nikon's microscope system, you purchase a scope, it's going to last a long time, and you're really at that point going to be upgrading cameras and software.
And I would just add to that, from Nikon's side, the stereo microscopes, the metallurgical scopes, the compound scopes are all available, as Gary and Rob said, as long as they have a photo tube or a camera port, that we can work with digital cameras and Elements. And the same for your existing microscope, regardless of brand. If it has a photo tube and you're not currently using a digital camera, we can provide the hardware that would allow you to mount a digital camera and work with Elements. Master Gage Tool also offers routine maintenance and cleaning of microscopes as well as part of our product offering. We're getting close to time to end the webinar, but we have another question. Which Elements version or module is best suited for 16232 particle testing?
That's a good one, because I'm not absolutely familiar with 16232. I know P82, and I know a couple of the pharmaceutical ones. So it all depends on, well, actually our particle testing module's the best because that's what it's for. What we don't know here is what size particles and that type of thing. And we need to know that information. We could Google that, gather the information, but I'm sure it's just min-max particle size and the number of particles. So our software handles that easily.
Yeah, for sure. It's if this customer has, assuming that's an ASTM standard or ISO standard, just I'm not super familiar with that either. It might be somewhat, it may be related to the filter analysis that I talked about earlier. But
we'll
so
take a note.
so we do that.
Yeah, we'll take a note and discuss it further with the customer. This is our last question. How does the lens quality of the existing microscope impact the image quality of the camera?
It absolutely impacts it. What you see with your eyepieces or what you're going to see with the camera in a sense. So if you're getting a muddled image through your eyepieces and your eyepieces are good because your scope has oil on the objectives or something like that, we can't make it any better than it is. So we can't, in a sense, improve the image you're receiving. What we can do is gather a maximum amount of data from that image. But unfortunately, if your microscope's that old and it's dirty, that we need a good image to work with for the best results.
Okay, thank you. Well, that concludes our Q&A session of the webinar. Is in coordination with this webinar, Master Gage Tool and Nikon are offering a 15% discount through April 30th off of software, digital camera, and microscope packages. At this time, I'd like to remind you that the handouts of today's session are available for download in the upper right-hand corner. All participants will receive an email with the product information, the webinar handouts, and a recording of today's session. If you're interested in an on-site visit to discuss a specific application, please contact me, Chris Hudson, at Master Gage Tool. I've included my contact information in the chat with my phone number and my email. In addition, you may visit our website for products and services outside of this topic. So once again, we really appreciate your attendance today, and we look forward to hearing from you on how we can help you with your metrology needs. At this time, we'll conclude the webinar and hope everyone has a great day.
Thank you, everyone, for joining us. We appreciate it.
Thanks, everybody.